Good evening to all of you. Welcome, you guys. Good evening. Welcome, you guys. All of you, welcome. Yes. How we people are doing? All of you, do comment in the comment section. All of you, do comment in the comment section. All of you. Yes. Chalo. Let's start our discussion. All of you. The discussion here. So here, first I'm going to announce one important announcement to all. And this 31st, that is this Monday, this coming Monday, we are going to start one new batch, that is a fast track batch is going to start. Fast track batch is going to start. This fast track batch, here we are going to discuss about all the variety of problems we are going to discuss. All the variety of problems we are going to discuss. All the DPPs, what are the DPPs are pending, all the DPP problems we will discuss there. Fine. Let's continue our session, all of you. Let's continue our session here. चलो हम शुरू करेगा. Let's start our discussion, all of you. Now tell me this. See the problem here. See the problem in the circuit shown in the figure. The effective resistance faced by the current. The effective resistance faced by the voltage source they are asking to find. Right. And you can see this is. Now this is the current I. I is passing here. Now this current is given as I by 3. So then how much this current I can say this is? Yes, this must be 2I by 3. Then this is the 2I by 3, isn't it? So can we apply the KVL in this loop now, inner loop? We can apply the KVL in the inner loop. Yes. Tell me, if you apply the KVL in the inner loop, what will get now here? This is V is equal to 3 into what we can say? 2I by 3. So that means what will get now here? 3 will get cancelled. So this is V by I, which is equal to how much will get now? 2 now here. Where this V by I, that is nothing but resistance faced by the given current voltage source. This is the resistance now here, that is a V by I. Done. So what's option now? Option B. Chalo, next problem. And chalo, next problem. Tell me this problem here. Here this is 5 volts. They are asking to find total resistance faced by the voltage source having 0 internal resistance in the circuit. This is 5 volts, and that means this voltage also 5 volts. From this, can I get this current now here? How much this current is? 1 ampere. Now here this also voltage is 5 volts only. So I can get this current, I can get how much this current is now here? This is a 0.5 amperes. This current is 0.5 amperes. Now the total current, how much this value now here? This is 2 amperes. So I can find the equivalent resistance of this network. If I say this is R equivalent, what I can say this R equivalent now, tell me? Which is nothing but the total voltage by total current, I can say. This is nothing but V value, it is a 5, and then how much this total current is? 2 amperes. So from this what I can say? 2.5. Yes. How much this resistance is? 2.5. All of you done. Completed this problem. Yes. Next problem. See this thing here. A 12 10 volts battery with an internal resistance of 1 ohm is connected across a non-linear load and whose VI characteristics is given as this much. The current delivered by the battery is, then the current delivered by the battery is they are asking to find. Yes, they get the VI characteristics is given as this much here. A 10 volts battery of internal resistance is this is connected to a non-linear load. Means what we can consider here, a 10 volts battery having internal resistance is given as a 1 ohm and this is 10 volts. Yes, this is connected to some non-linear load. Here this is my load. This is a non-linear load. Having a VI characteristics is given as this thing. VI given like this. Now, so what I can do here, tell me now here. This is 1 ohm. So if I apply the same I will pass here. If you apply KVL in this loop now, tell me what will get now here. This value is given as 7I. This value even characteristics given as 7I is equal to V square plus 2V they given. Yes or no? Now what we can say now here, this the same current will flow here. Then how much this voltage here it is a, this is voltage is I. Now if we apply KVL in the complete network, what will get now here? This is equal to 10 equal to what now here? I plus V. From this can I get my V now here? Now we can get. Let us get this I value. I value same now, same kind will flow. If I get this I value, I is equal to what now here? V square plus 2V by 7. I can replace this value here. 10 is equal to I we have, this is V square plus 2V by 7 plus V, which is equal to 10 is equal to V square plus 2V plus 7V. I can say this is 70, isn't it? So V square plus 9V minus 70, which is equal to 0. Check this thing all of you. From this can I get my V value? So 70 roots we can tell me now here. Yes, roots what we can say here, 70. So this is 10 into 7, 9 we should get now here. 2 into 5 into 7, what we can say roots now here, it is a, so sum we should get it as a 9 we should get, and product is a 70. How is it possible now here? Sum 70. Tell me the roots now here. Hmm? Fourteen into 5, this is what we can say 9 na? So what we can say, this is, yes, plus 14 into minus 5, isn't it? So what we'll get now, this is V minus 14 into V plus 5, which is equal to 0. Check it now here. So from this what we can say, V value is equal to 14 or V value is equal to what now, minus 5. So since they are saying this as a source, this should not be, we can take this as V value 14 only. Yes, so got this thing now here. So 40 is the answer. Chalo, next problem. Now tell me this thing here. Now here I think we did this type of problem in the class also. Now tell me this answer for this thing here. Do it now here all of you. All of you, all of you do it. Join and try to involve in the class. All of you try to involve in the class. Try it. Yes. First we need to get the E now here. How to get this E now here? This is 0 volts and here this is the positive and we should have negative now here. This is the ground. This ground and this ground is connected, isn't it? We can apply the KVL in this loop now here. KVL in this loop now, and this voltage is V, this is plus, this is minus, and these two grounds are connected like this now here. All grounds are connected. I can apply KVL in this loop now here. Yes, what else now? V2 also we should get. To get this V2, what we can do? This is positive and here it is negative, and this negative, this ground is connected. I can apply KVL in this loop. Yes. Now done with the KVL in this loop now here. Yes, if I call this is the first loop, let us the second loop, and this is the third loop. Turn with the KVL to the first loop now here. If I apply the KVL to the first loop, then you will get, what will get now here? Plus E, yes, plus E, plus 5, plus 10, minus 0, minus 1, which is equal to 0, plus 1. No? Okay, so that is E is equal to how much now here? Minus 16. And for the KVL for first loop now, and for second loop if you apply KVL, so this is plus 5 plus 10 minus V1 minus 4 equal to 0. So that is V1, which is equal to how much now? 11. V1 is 11. Next KVL to the third loop. What will get now here? This is minus 1. Yes, what now? Plus 0 minus V2 minus 2 equal to 0 plus 2. So that is V2 is equal to how much now here? 1. V2 is equal to 1. All of you done this thing. All of you do like the session. Everybody completed this thing here. We got the E value, V values, and V1, V2's values we got now. Fine. Next problem. See this thing here. Assuming the ideal elements in the circuit, the voltage VAB. I want to find the voltage VAB. Tell me the voltage VAB now here. This current is how much it is? 2 amperes. This current is 2. So can I get this voltage here? Now this voltage how much now here? 4 volts now here. So this is a positive, this is the negative. Now I can apply KVL in this loop now here. If you apply KVL in this loop now, tell me what you will get now here. What will get now? This is plus 4 minus 5. This minus VAB, which is equal to 0. The voltage at any point always with respect to the ground. So this is a ground. So from this finally we got the VAB. How much is VAB now? Tell me here. Minus 1. Yes. And done all of you. We'll go to the next problem. Next. Yes, next, tell me the next one here. Now, I want to get this V here. This is the V here. Now, this current is 2 amperes. So, that means we'll get this voltage. How much? This is the 4 volts. This is 5. And here, this is some element is there now. Let us call this is something X. Tell me now here what will get. V is equal to what now here, x plus 4 plus 5. That means V is equal to how much it is, a 9 plus x. Now what about this x is a, what is this x value? This x is nothing but what now, that is a voltage across the ideal current source. How much the voltage across ideal current source? How much this value of this x now? The voltage across ideal current source, it can be any value. The voltage across the ideal current source can be any value. It may be a positive, it may be a negative, it may be 0 also. It may be positive, maybe negative, maybe 0 also. So here we don't know how much is x value. Without knowing the x value, we cannot find this thing here. Without knowing the value of x, we cannot find the value of V now here. V is not possible to find. So this means what we can say here, V not possible to find. So the data is insufficient. Without knowing the value of voltage across the ideal current source, not possible to find. Rajesh understood this point? Rajesh understood this point? It may be a positive. The voltage across the ideal current source. Write down this point here. Voltage across ideal current source. Ideal current source. How much it is? How much it is? Can be any value. We don't know here. That will be depends upon the interconnection of these elements. Yes, the voltage, it may be a positive, maybe a negative value also will happen, and even sometimes it may be 0 also will happens. Done this thing, a point. Understood this point all of you? सब लोग ये point समझ गए सब लोग? चलो next point. Now see this thing, let us solve this problem here. Let us solve this problem here. Now this is the V1 is given here, this is the V2 is given. Fine. This voltage is always with positive and this is with respect to ground, isn't it? This is positive and this is with respect to ground here. Now here these two grounds are connected. These two grounds connected now here. So we are applying the KVL in this loop we are applying. Can we apply KVL in this loop now here? Tell me. If we apply KVL in this loop now here, see the loop we have, what we have taken. This is what now here, minus V1, isn't it? Minus V1, and we don't know the voltage here. Let us call this voltage, I am calling as something X, and this voltage I am calling as something Y. Consider. Fine. Minus V1 and what now here, plus X, then minus 1, and then what now, plus Y, and then plus V2 equal to 0. Yes, so to get this thing, to get these values, we need X and Y values. So here this is the flow of current is there now here. How much this current will flowing now? 1, 1, 3. So this is how much this current is, I value in this loop is 1 by 3. So from this X value, how much it is, 1 by 3 here. Now the current will flows in this loop now here. I value in this loop is what now, 1 by 2. So this Y value, how much it is now here, same path. So this is also equal to what now here, 1 by 2. Replace the value of X and Y. So this is minus V1 plus X is 1 by 3 minus 1, Y is 1 by 2 plus V2, that equal to 0. So this means what we can say, V2 minus V1, which is equal to what now, 1 minus 1 by 2 minus 1 by 3. Check it now here, how much it is now, 6, 1, 3 minus 2, isn't it? So this is 1 by 6. Check it all of you, what you got the values now here. So finally what we can say, this is V2 minus V1. How much it is now here? 1 by 6. V2 minus V1, how much it is? 1 by 6. Done. Got this thing? Yes. Fine. We'll move to the next problem, all of you. Got the same thing now, everybody? Yes. Yes. All of you do like the session, everybody? Do like the session. All of you. Done. Chalo, next problem. And see this problem. Find the value of Vx. Find the value of Vx. The Vx value, I want to get it now here. So now here, this current, if I say here, this Vx now here, there is some voltage, let us call this is some X we are calling. One second here, and this is Vx. Okay, now here this, so if I call this current now here, so how much this current is now? This current is also Vx. Now here we'll get this voltage, how much this is? 5Vx, isn't it? 5Vx. Now here there is no flow of current, there is no flow of current, current equal to 0. So then this voltage is 0 already. 0. If we apply KVL in this loop now here, apply the KVL in this loop, what we'll get now here? Yes, plus X plus 0 plus 5Vx minus Vx equal to 0. So that means what we have now here? So this is 4Vx, which is equal to X now here. So that is Vx minus now, minus Vx is equal to minus X by 4. Vx is equal to minus X by 4. So X value we should get now first. X value is this voltage now here. How much this X value, which is given as what we can say 2 by 2 plus 2 into 8. So this X value is equal to how much now? 4. So from this what we can say now here, this is minus 4 by 4, which is equal to minus 1 volt, isn't it? Done, all of you? Yes, got this thing here? Yes, somebody has given one question here. Okay, the current through the 100 microfarad capacitor is given as like this. Calculate the voltage across it at t is equal to 1 milliseconds and t is equal to 5 milliseconds. It's simple now here. What happens this thing here? They given, see the problem, somebody asked in a comment section, I'm solving this problem and you also try to solve this problem. I is given as, I of t is given as how much it is now here? 50 sine 120 pi t. 120 pi t. Now we need to find the voltage now here. This is the capacitor now here. Capacitance value given as 100 microfarads. 100 microfarads you have. Now as we know here, V is equal to what we can say, this is 1 by C integral of what now? I into dt. I into dt. So they given the value. Yes. So now tell me now, if you do the, we got this thing now, I is equal to C into dV by dt. So from this V is equal to integration of this thing. Done this thing now up to here. Now so this is V value, which we can say this as, this is equal to V of 0 plus what now here, 1 by C from where to where, 0 to the present time, I into dt. In the problem they given the V of 0 value given as 0, fine, there is no problem. Initial value given as 0 given na, initial value how much they given, so this is 0, 0 plus 1 by C, yes, how much the C value, yes, 100 micro, 100 into 10 power minus 6, and this is 0 to t, and I of t will be this much now here, so 50 into sine 120 pi t milliamps, so this is into 10 power minus 3 into 10 power minus 3, so this V value what will get now here, this is 50 into 10 power minus 3 by what now here, this is 10 power minus 4 in the denominator, this is 50 into sine integration is what now here, minus, no 50 is already taken now, there is no 50 again, sine integration is what now here, minus cos 120 pi t by 120 pi, limits 0 to t. Simplify now here, yes, what will get now here, this is, if we replace now here, this is what will get now here, 50 into, this is 10 power plus 1, so it will become 500 by 120 pi, isn't it? When you lower limit, when you substitute now here, this cos 0 is 1 minus what now here, cos of 120 pi t. This is my voltage. This is a voltage expression. Now see what they ask you to find. They ask you to find a t is equal to 1 millisecond. So we can replace a t is equal to 1 milliseconds. Consider t is equal to 1 millisecond. Yes, t is equal to 1 millisecond. So replace the value now here, which is equal to what we can say, 500 by 120 pi into what now here, 1 minus cos of 120 pi into 10 power minus 3. Simplify, get this answer. And the same thing at t is equal to 5 milliseconds now. Same thing, t is equal to 5 milliseconds. So V value we can replace. Simplify, will get it, isn't it? And you can do the remaining simplification, isn't it? Who asked for this question? Some Sri Devi. Done this thing, will you do this thing? Remaining simplifications. Simplify this thing, substitute the values and do simplify it. Okay. Okay, fine. We'll move to the next problem, all of you. Done. Chalo, next problem. Now, see this thing here. The given IR of t is given as this much. IL of 0. IL of 0 is given as this much. Okay. Then they ask you to find the value of phi. They ask you to find the value of phi. Let's solve this problem here. All of you try this problem here. They given this is, can I apply the KCL at this node? By KCL at this node, what will get now here? So IL of t is entry current plus 12 into cos of omega t minus 5. This also entry current, which is nothing but what we can say, IR of t. Done. Now So I am considering that t is equal to 0 in the above equation completely. Consider t is equal to 0. That is IL of 0 plus 12 into cos of what now here, minus 5, which is equal to what now here, IR of 0. So they given IL of 0 given as 1. So this is 1 ampere. 1 plus this is what now, 12 cos 5, which is equal to IR of 0 means here we should replace t is equal to 0 in this equation. If we replace t is equal to 0, what we will get now? This is 4 plus 3. You will get this as 4 plus 3. So what we will get now here? 12 cos 5, which is equal to 6. That is cos 5, which is equal to 1 by 2. That means 5. How much is 5 value now here? Over na? Yes. So this is what now? Completed all of you. This much. We got this cos 5. Chalo. Next problem. Now see this another problem here. VR is given as a 5. VC given as a 4 sin 2t. Then they ask him to find the VL of t. Okay. Now see this thing here. This current they given as a 2 amperes. And the VR is how much it is? This is 5 volts. Now I can get this current here. How much this current is? This current is 1 ampere. This current is this thing here. Yes. Next, what else they given now here? They given VC of t is given. So from this, can I get this current now here? This current. How much this current is now here? This voltage we have given. I is equal to C into dV by dt. So this is I is equal to C value 1 into 4 into what we can say here? Yes, this is 8 now here. So this is 8 cos 2t I can say. This current is 8 cos 2t. Now let us say this current is something I मान लो. We can apply the KCL at this node. KCL at this node if we apply. Now tell me this thing here. KCL now here. 2 is a entry current. 1 is also entry current. And yes, here minus 8 cos 2t is a leaving current now here. You can write right side if you want. Yes, this is the leaving current, and which is equal to, I can say this is I now here, I. So that is how much is I value now here? 3 minus 8 into cos 2t. This is the current through the inductor. Now I need to get this voltage across inductor, VL of t, which is equal to what now here? L into di by dt. So this is L value given as a 2 into this differentiation 0 minus 8 into 2 into sine 2t now here. So this is how much now? 32 into sine 2t. So this is the VL of t. Done all of you? Got the same thing? Yes. Done. Next problem. Find Vx and Ix in the circuit shown. Find Vx and Ix in the circuit shown. See what we'll do now here. Vx and Ix. Here they given this value. Vx and Ix. This current is given 5. I can get this voltage. Now how much this voltage? 40. Yes, this is 40. Then how much this voltage? I can say this is 20. Yes, this is 60 now. 40 and 20. Now can I get this current now? Tell me. Yes. How much this current is a? So this current is 2 amperes. This current is 5 amperes. Means this current is 3 amperes. So I can get this voltage. How much this voltage is a? 12. Yes, now I know this voltage. This is 20, this is 12. Can I get this voltage now? How much it is a? 8 volts. Any doubt here? Yes. 12 plus 8 is equal to 20. Now can I get this current now here? How much this current is a? 4 amperes. This current is 4. This current is 3. Isn't it? Means what now here? How much this current now here? This current must be a 1 ampere. This current must be a 1 ampere, then only it can satisfy now. So this current is 1 ampere. Means Ix value equal to 1 ampere ho gaya. Now this voltage means this voltage only now. How much this voltage? 8 volts. So that is Vx is equal to how much now here? 8 volts. Yes, everybody done this thing. See this thing, how to approach the way of approaching the problem. Done. We'll move to the next problem. Yes, let's try this problem. Let's try this problem. Check that one here. Only simplification is important. Check that value simplifications. Do the verify the simplifications. This problem na. Verify your simplifications carefully. Did you verify the simplifications or not? Only this is the method. This is only the thing here. This is only the thing here. Simplification you do verify once. How much it is now here? We'll get now here. You can see. Yes. Yes, answer is correct. Answer I got this thing as a 93.13 milliseconds. This is the answer. I got this much. Yes. How much you got, Sri Devi? This is the answer I got. 93.13 millivolts. Sorry, millivolts. This is the answer we got. This is the answer. How much you got? You check it. This is only the answer I got. You might did a calculation mistake you did simply. So this thing here I got my just now I verified with my calculators. I got this much 93.13. Okay. So I think you might did the mistake here. It is a 120 pi. you might do the pi value you might taken this as a 22 3.14 you have taken might be, that's the reason here the pi is 180. Pi means what now? 180. Here the pi is a 3.14. Okay, so here the pi is a 180. That might be the mistake here. Yeah, this is the mistake here. You take here this pi is a 180 and this pi is a 3.14. That is a mistake you might did. Okay, you do verify it. Then you will get this correct answer. You will get. Fine. Chalo. Now let's solve this problem here. Now you tell me this thing what we'll do here. Yes. Now this current is how much it is a 1 ampere. This current is 1 ampere. Yes. This current, if I say this is my IN. Now this current is a 6 amperes we are getting. Right. Now yes, got the answer now. Now this is a 4 amperes. This current is 4 amperes, isn't it? Now this current is how much? It is a 4 Vx. This current is 4 Vx. Fine. Now tell me this thing here. This is IN. IN I want to get now here. So here this is 1 ampere is going here. This is 6 is coming. Yes, here this is 1 ampere means this current must be how much it is a 5 amperes. This current is a 5 amperes. Right. This current is 5 amp. Entry current is a 5. Now here this current must be also 5 amperes. Yes or no? Whatever the current here, some current may go here, some current here, but finally this must be 5 amperes only. This current is 5 amperes, isn't it? If this current is 5 amperes, and then means what now here? The 4 amperes are going here, isn't it? Then how much this current should go here? This current must be a 1 ampere. Yes, that means what we can say this is, yes, 4 into Vx, which is equal to minus 1 ampere. That means Vx is equal to how much now here? Minus 1 by 4. Vx is equal to how much it is a minus 1 by 4. Vx we got this voltage. Means this is this polarity is positive, this is negative. How much this voltage is a? This is 1 by 4. Then this current, how much this current is a? Yes, this I value. How much this I value here? This voltage is a 1 by 4. 1 by 4 by 4. This is 1 by 16. 1 by 16. Now this current is a 1 by 16. Now this 1 by 16 is going here. Means remaining current is here only now here. How much is IS value here? 5 minus 1 by 16. 5 minus 1 by 16. So how much is IS value? Tell me here. Yeah, take LCM and simplify it now here. How much you will get nearly? Yes, all of you. Yes, 1 by 16 minus 5 minus 1 by 16. You will get this as how much now? 4.93. So this is my IS value. Yes, this is IS value we got. And then what else we should know? IN. So how much is IN now here? Yes, this current is 1 ampere. Now here this current IN is also negative. Yes, this current is 1 ampere is going, isn't it? Right. Done, all of you? Completed? Everybody? Yes? Completed now? Everybody this thing? Yes? Any doubt in this thing? Fine. Next problem. Now tell me this problem. Find I. I they ask him to find here. This current. Here this current is 1. Yes, so this voltage. How much this voltage is a? Yes, 4R. Now this voltage also 4R only. Yes or no? That means this current is a 1 ampere. This also 4R. That means this current. How much it is a 2 amperes? Yes. This current is 1 ampere. This current is 3. Now this current is how much? 3 plus 1, 4 amperes. Means this voltage will get how much it is a 12R. Now this is 12R, and here this voltage, how much this voltage is a 4R, means this voltage must be 8R. Now this voltage also 8R, that means I is equal to 4 amperes, isn't it? What IS? IS we didn't get. IS we calculated now. What happened now? IS value, isn't it? Yes or no? Got this thing IS value? Omkar, what happened? IS value you didn't get? We got now? What happened? Yes, any doubt in this thing? Omkar, shall I repeat this thing? Now see this thing here. IS value we got it now here, this value. Okay. No need now. We'll move to the next problem. Okay, then tell me this thing. Any doubt you can ask. Any doubt you can ask. Right. Now tell me this current now he given as a 4 amperes. Here they are asking to find this Rx value. Let's see this Rx value. Now, so then this voltage, how much it is a? 16 volts. Yes, this voltage is 16 volts. Fine. Now this current is 10. Then how much this current now here? This current is a 14 amperes, isn't it? Yes. And this current is a 6 amperes is coming. Means this is 8 amperes now here. Mean this is 8 amperes. That means this current is how much it is a 2 amperes. And this current is how much? 2 amperes. Yes or no? Now this is 4 amperes. Now again this is the 6 amperes. This is the flow of current in the loop. This is the flow of current in the loop. Now tell me what I want here. Rx value I want to get. let's try it now here. Now I can get this voltage is how much now? 4 volts. This is how much it is? 60 now here. Then how much this voltage now here? 70. Mean this voltage also same voltage, same 70 volt only now. Yes, I can apply the KVL in this loop now here. If we apply the KVL, tell me what we'll get now here. This is minus 70 plus 2 into Rx plus 4 minus 16 equal to 0. Check this part. So we got like this now here. So this is what we'll get now here, 2Rx, which is equal to 70. This is 86 minus 4. This means what now? 82. So this Rx is how much now here? 41. Check it. Rx is equal to 41. Yes, all of you done this thing? Everybody? Next problem. Find Vx. Find Vx. Now let's see this thing, how to find this Vx value. Now this is the open path, so there is no flow of current here. Okay. Now if I call this current is something I, now this voltage, how much this voltage is? 5I. So I can apply the KVL in this loop now here. I can apply the KVL in this loop now here. Tell me, if we apply the KVL in this loop, what will get? This is 5I minus Vx minus 12 equal to 0 now here. In this resistor, there is no voltage value 0 now, since current is 0. Now I can apply to get this current. I will apply the KVL to this outer loop. To get this current, I will apply the KVL to this outer loop. Now, so this is Vx, which is equal to 5I minus 12. If you apply KVL to the outer loop, what you will get now? This I value, which is equal to 20 by, so 10, which is equal to outer loop current. So this is Vx is equal to what now here? 10 minus 12. So Vx is equal to how much now here? Minus 2. Check it, all of you. Yes? Done. Chalo. Yes. Yes. Okay, then if you have any doubts, you can message me. We'll discuss all the doubts, we'll discuss all the problems, we'll discuss. It's a simple problem, don't worry. It's a very simple, basic problem, and here we used to do the very advanced problems. We are going to solve it. Yes. Yes. Let's try to solve these problems. Now tell me. Yes. Now tell me now here, this voltage which is equal to how much it is, 60 volts, and this voltage is how much it is at 20 volts. The current will flows in this loop, isn't it? Current will flows in this loop now here. Yes, so now at this location, now here we can apply the cable in this loop now here. Apply the cable in this loop now here. If we say at this location, the voltage we got this one, this voltage we got this as a 60. I am calling this is my ground here. So then this is not a ground here, remember. Okay, only this is the ground here. This one, only one is a ground because of this resistance. Okay, now what we can do here, this voltage is 20, means we'll get this current, will get it now here. How much this current is a, how much this current is a, this current is 4 amperes. This current is 4 amperes. Next, this current, how much this current is a, 6 amperes. Fine. Now this current is 6 amperes here. We need to get this current, we should get now I value. What we can do here, so this is another node now here. We don't know how much this voltage here. Yes or no? This is another node here. Let us call this node voltage is something V5 मान लो. Yes, if I consider this voltage is V, now tell me what we can do here. This is 60. Now this is 6 amperes is going here. If this resistor is not present, then the answer is very easy, isn't it? If I don't have any this resistance, then what's the answer now I can say? If this is, then 60 minus 20 by 2, that is directly will get. But because of this resistance, this point is not a ground. Only one ground is there. This is the ground here. Because of this resistor, this is not a ground. Understood what I am saying here? So here this is one crucial point here. This is one crucial point. So because of presence of this resistance here, because of presence of this resistance here. Now what to do here? Tell me this thing. What to do now here? Tell me this thing here. This voltage is 60. We got it now here. This is my ground we considered. This is 60 volts. This voltage here. What we can do now here? This resistance you'll see. Bolo yaar. This resistance value 5 will get this current is 4 amperes. We got it. Now what I can do? This current is 4 amperes. This is I. Yes. Now this value, how much this current is now here? I minus 4 I can consider. I minus 4, isn't it? Now if I say this current is something, let us say X now here, this is 4, then how much this is a? X minus 6. Now this is easily I can take things now here. This is X minus 6. Now this is X minus 6. Now this 4 is going here. 4 is going here. That means this is X minus 10. Now that means this is X minus 10. This is X minus 10. This is how much it is now here? 4 is coming. Then this is how much now here? X minus 6. Now this is X minus 6. This is X minus 6. This is what now here? X will go finally. Yes or no? Now what I am doing is simply let's try to apply the KVL to this outer loop easily. KVL to this outer loop now here. Tell me the KVL to the outer loop now here. If we apply this thing, what will get now? 2 into X minus 6 plus 20 plus 3 into X minus 6 minus 60 equal to 0. Yes, so from this we'll get the X value. How much this X value now here? 2x plus 3x, that is what now? 5x yes, which is equal to 60, yes, minus 20 plus 12 plus 18. Check it now here. So this is 5x is equal to 30, 30, 60, isn't it? No, 60. So sorry, what it is? How much is value? 1 second. So here 40, 40 plus, yes, this is 30, 70 now. So x value how much now here? 14. X is 14. If x is 14, this current is 14. Now this is 6 is going. Then how much is finally I value now? Tell me. How much is finally I value? I can say this is now here 8 amperes. Check it all of you. Yes, everybody. Done. Got this problem all of you? See the here, because of this resistance, see this thing, the problem will becomes like this. So this resistor is a crucial. If there is no resistance, directly answer is what now here? If there is no resistance, the directly answer will becomes what now? 60 minus 20 by 2 directly will get. But because of this resistance, the complete analysis will changes. Done all of you? Right. Fine. Yeah, that's for today's class, and tomorrow we'll meet the same time at, yes, 6 p.m. to 7 p.m. Tomorrow same timing, 6 p.m. to 7 p.m. And if you have any other problems also, get those problems. We'll discuss all the problems we'll discuss in the class. Fine all of you? Okay, then we'll meet in the next class. Tomorrow we'll meet at 6 p.m. to 7 p.m. Okay, then see you. Bye bye.